So here's the video solution for quiz on learning targets 3.05b and 3.05c. So first, let's read the question. Stan has decided to go sledding on a frictionless hill. The hill is inclined at 4 degrees, and the hillside, the face that Stan is sliding down, is 20 meters long. If he gets on the sled at rest and begins accelerating at 0.7 meters per second, how long does it take him to reach the bottom? Quickly sketch the scenario above using labels to identify variables. What is his final velocity? So, let's highlight some important information there. First, what are we trying to find? What's his final velocity? And how long does it take him to reach the bottom? And we want to sketch the scenario. That should go without saying. So the first thing you should always do is kind of draw a picture just so you have an idea of what's going on. So we have a 4-degree incline. We have Stan up here on his little sled. And he's coming down the mountain. We know the length of this mountain, or hill I guess, is 20 meters. Alright, so that's a pretty good picture that we have right there. Now, let's write down some of the variables that we know. So what information is given to us? Well, 20 meters long, that's going to be our change of position. He goes from the top of the hill to the bottom of the hill. So the change of position is going to be 20 meters. Good. Alright, what's next? Well, so we have that bit. 4 degrees already labeled. That's not really going to help us too much, I don't think. Gets on the sled. Oh, it's at rest. Well, I guess that means that his initial velocity when he starts is going to be 0 meters per second. And then we say we're accelerating at 0.7 meters per second. So his acceleration is 0.7 meters per second squared. Alright, good. So I think I'm going to choose to do a mathematical solution here. So here are the 3 equations that we have for kinematics. These 2 we derived in class, this being the slope of an acceleration time graph, and this being the one that we derived from the slope of a velocity time graph, and this being the one that I gave you today on the quiz. It looks to me like the easiest equation to use would be this one right here, because I'm given delta x, given acceleration and initial velocity, and one of the things I'm looking for is final velocity. So I'm going to be using v final squared equals v initial squared plus 2a times delta x. Always write the equation first and then plug in what you know. So what do I know? Do I know v final? I do not. So v final stays as a variable. V initial I do know is 0. So 0 squared is still going to end up being 0. We know that the acceleration is 0.7 meters per second squared. And our change in position, delta x, is 20 meters. Let's clear up some room here. Alright, so let's do some math now. So, v final squared, we keep that alone. 0 goes away. 2 times 0.7 is 1.4. 1.4 times 20 is going to give us 28. And now we take the square root of both sides. So we get v final is equal to approximately 5.29 meters per second. Alright, good. So we have one of the pieces of information that we're trying to find. What else do we need to find? Well, looking back, it said that we were also looking for how long it takes him to reach the bottom of the hill. Okay, so if we want to know how long it reaches him, we're looking for delta t now. So delta t, we don't know. Again, looking back at the equations we have here, well, now that I found the final velocity, I can use our equation for acceleration, because I have the acceleration, the final velocity, the initial velocity, and all I'm solving for is the time. So, if acceleration is equal to v final minus v initial all over delta t, if I want to get delta t by itself, I have to multiply both sides by delta t. These two delta t's divide, multiply this side by delta t as well. So our new equation looks like delta t times the acceleration is equal to v final minus v initial. Well, let's plug in what we know. We don't know what delta t is, so that stays a variable. The acceleration we know is 0.7. The final velocity is 5.29, and our initial velocity is 0. So, to simplify, we have to divide both sides by 0.7, and we're left with delta t equals 7.56 seconds. So if you want to rewrite this as a sentence, you can, but our two answers are as follows. We have v final is equal to 5.29 meters per second, and delta t is 7.56. It is good to box your answer, so it's easy to find. And now we'll move on to the next question. Alright, so Kyle rolls a ball off of a 100-meter cliff. Initially, its downward velocity is 0 meters per second. It accelerates at a constant -10 meters per second. What is the downward velocity of the ball, the instant just before it hits the ground? How long does it take the ball to fall to the ground? So let's sketch this scenario again. It's always a good idea to draw what the picture looks like. So we have a 100-meter cliff. We have a ball that starts at the top and ends up falling down to the bottom. We know its initial downward velocity is 0 meters per second, but it does end with some sort of downward velocity at the end. Just like we did before, let's write down what we know in terms of variables. Actually, let's highlight what we know in the question first. Right now. So first of all, we want to know how long it takes the ball to fall. We want to know the downward velocity just when it hits. And what do we know? Well, we know it's a 100-meter cliff, but let's be careful. Delta x is x final minus x initial. So what's the final position of the ball? Well, this is the final position of the ball. If this is height 100, then the final position is 0. So 0 minus the initial height, which is 100. So delta x is negative 100 meters. What else do we know? Again, initial velocity is 0 meters per second, and our acceleration is -10. So again, looking at our three equations that we have, I think I'll use the second one because I've given delta x, initial velocity, and the acceleration. And all that I have left to find is just my delta t. So, as always, rewrite our equation. Delta x is equal to v initial times delta t plus 1 half a times delta t squared. Fill in what we know. We know delta x is negative 100. Initial velocity is 0. So this whole term becomes 0. Plus 1/2 negative 10 times delta t squared. Let's simplify a little bit. Negative 100 is equal to negative 5 times delta t squared. Divide both sides by negative 5. So we get 20 is equal to delta t squared. So take the square root of both sides, and we get 4.47. So delta t is equal to 4.47 seconds. Good. We have delta t, but I think we're also looking for our downward velocity at the end. So we need to find v final as well. So let's find v final. Looking at the equations that we have to choose from, now we have delta t, we have our initial velocity, and we have the acceleration. So I'm just going to use this first equation. So acceleration is equal to v final minus v initial over delta t. Acceleration is negative 10. V final, we don't know, so we leave that as a variable. V initial is 0, and delta t is 4.47 seconds. So if we want to get v final by itself, multiply both sides by 4.47. So we get negative 44.7 equals v final, because 44.47s divide to 1. So v final equals negative 44.7 meters per second. Now, it's important to note here, what does this negative sign mean? Well, if we take something and then drop it off of a roof, the velocity starts at 0, but you're being increasing downwards. So if we have a downward velocity, we're going to have a negative sign associated with it. All right, so those are the solutions for the quiz that we took on 3.05B and 3.05C.